Whenever you're writing a program that contains functions, then it's not unusual for you to declare variables that are in the main program, variables that are in the functions, and you might even put some variables here above the main program that we would call global variables. Well, there are rules that govern how these variables are used, and in some instances, how long these variables actually live, which means how long do they have a location or an address in memory. What I want to do with this program is to use some really very simple functions to illustrate these rules that govern variables, and these are called scope rules. We'll also look at static variables, and we will look at passing arguments by reference and by value, that is, passing information from one function to another by these two different techniques, reference and value. So these are very short functions, but there's a lot of information here. Let's begin with some function prototypes. Here you'll see that I've named these functions just function 1, 2, 3, 4, and 5, and they're all type void, so we'll talk about type void. The main program, it just has a few variables declared for x, a, and b, and then I've got some skeleton functions down below where the bodies of the functions are lived. That's where they exist. Then we are going to add some code to these functions, and then we're going to analyze how the data is passed around and what the rules are for the different variables. To begin with, let's just start with our main program, and let's print out something really simple. These are going to be some simple outputs and some simple statements that are easy to understand. So the first thing I want to do is to just do a cout statement here, and we'll print out the value for x. So that's very simple. Here's the line of code to do that. It's just a cout statement. So in the main program, x is equal, and we'll print out the value for x, and it comes as no surprise to anyone that the value for x will be 1 here. Now let's go down to our first function called function 1, and let's put some code in there as well. So here we are in function 1, and I'm declaring a variable x, and I'll set it equal to 2, and we'll print out the value for x in function 1. So when we print this out, you'll also not be surprised to see that we get the value 2 here. So we have, within function 1, we have a variable x, and if we look in the main program, we have a variable x as well. So there are two variables that have the same identifier, but they are different variables entirely. That is, they are located in different address locations in memory. This x is said to be local to the main program. So that's local to the main program, which itself is a function. The main program is also a function. Within function 1, this x is local to function 1. So these variables do not interfere with each other. The x equals 2 in function 1 is completely different than the x equals 1 in the main program. Let's just put a comment here that does state what I just said, that the variable x is local to this function. It is not the same x that's in main. So that is the scope of x then. We have a local scope for x in function 1, a local scope for x in the main program. Now, let's come back and let's print out some information again in the main program. Now we're back in the main program, so let's put a call to function 1, and then when we return from function 1, we'll print out the value of x once again. So when we run the program, and I'll do that shortly, then we will see x printed out in the main program. We'll go to function 1, and we'll print out the x there. Then when we return from the function to the main program, we'll print out the value x again. So let's compile and run the program and look at the output. Now we have the output. Let's bring that in. So we can see that we print out in the main program local x is 1. Then we call function 1, and in function 1 we print out its x, which is 2. Then we come back to the main program, we print out x, which is 1. So this shows you that the x that we have declared here in the main program is different from the x here. They do not interfere with each other. The scope of this x is function 1. The scope of this x is main. Now let's add a global variable. Global variables appear above the main program, and I'm just going to declare an integer y, and I'll set it equal to 3. This is a global variable. What does that mean? Well, a global variable can be seen by all functions. So that's it's available to all the functions, and when we put it up here, like we have done all of these other stuff, everything that's up here can be visible or is visible to all functions. So even though we haven't talked about it, these prototype definitions and even these pound includes, all the stuff that's in there, that is all available to all the functions that we have in our program. Inside these curly braces, what's in there is local to whatever function that is. So I've declared a global variable, and I've just called it y. I've set it to 3. Now, let's add some lines of code to our functions and see how we can access that global variable y. Okay, so in function 1, let's paste a line of code, and we'll print out the value for y. So in function 1, global y is equal to, and we print out the value for y. Okay, so there is no y within the body of this function. And when you try to print out y, the only place it can go to find it is a global variable. So since we have a y that's global, this is the one that it prints out. So the y value is accessible to function 1, and it's available to all the other functions as well. Let's add a line of code in our main program where we will print out the value for y. We'll print it out here, and then let's call function 1, and it will also print out the global variable y. So now we are going to call function 1, and we'll get those two output statements. Let's compile and run the program. Now let's look at the output from the program. So now we can trace our way through the output. So in the main program, we still get x is 1. We call function 1, its version of x is 2. And then in function 1, we print out the global variable y, which is 3. So this is what you would expect. So in the function 1, we have the global variable, and we have x, which is its local variable. Then as we return to the main program, we print out x is 1. And we want to print out y in the main program as well. Okay, so we print it out here. And in the main program, we don't have a variable y, so it prints out the global variable y. So we get that. So then we call function 1 again, so I'm kind of repeating these two lines. So we get x and y here when we call function 1, and then we get the same two outputs when we call function 1 again down here. So this shows you then that we can access the global variables and the local variables. Now let's add some code to function 2. So I'm just going to put a line of code in here, which is a cout statement, and in function 2, we will print out our global variable y. Well, there are no local variables in function 2, so there's no y that's local here, and when we print out y, it will be the global y that we're printing out. But before I do that, I want to add a little something extra up here. So let's go back to the very top, and let's declare an integer x, and let's set that equal to 4. Now, let's see what happens when we run the program this time. Before I bring the output in, what do you think will happen? I've declared a global variable x up there. And I just said that every function can see global variables. I've got this local variable x in main, and I have this local variable x in function 1. Will that print out 4, or will it print out 2, or will it print out 1 when I'm in these locations? Well, here's the output. Let's take a look at the output. So in the main program, x is still equal to 1. In function 1, x is still equal to 2. And when we call it again, function 1, it's still the same thing. X is equal to 2. So nowhere in this output do we print out the value 4 for x. Now, before I explain this further, let's go back and let's add a line of code into our function number 2, and we'll call it. Okay, so here we are in function 2. Let's put the line of code in here. And now we're going to print out the value x in function 2. Function 2 has no local variables, so we would expect that we'd print out the global y and the global x, so we get 3 for y, and we get 4 for x. So now let's go to our main program, and let's call function 2 right down here. Okay, so let's paste in the call. So we're calling function 2. Now let's run the program again, and let's look at the output. Okay, so now let's bring in the output. Okay, so we bring this in, And we can see that when we call function 2, then we print out the value for y, which is 3, and we print out the value for x, and this time we get 4. So in function 2, we're referencing the global variable for x, whereas in function 1, we're referencing its local variable. In the main program, we're referencing the local variable x here. So that brings us then to the actual statement, I guess, of our scope rules. So let me move this out of the way, and I am going to state them. And it goes like this, okay? Whenever you have a variable that's declared within a function, including main, then that x is the scope of that x is within this body of code only. No other function can see it, no other function can change it. So a local variable is visible only within the body of the function where it's defined. So we see that in the main program. We say that for x equals 2 in function 1. When you have a global variable, like we do here with x is equal to 4, then if there are no local variables with the same name, then x is printed out as the global variable. If there is a variable with the same name in a function, then the local variable takes preference. Okay, so that's the big deal here. If you have a local variable that has the same identifier as a global variable, the local variable takes precedence. So that's the scope rule. And with a global variable, if a function happens to change that global variable, then it's changed for everybody. So it only has one location in memory, and if a function changes that global variable, then it's changed for everybody. Now, let me talk about the void function a little bit. These functions are declared to be a type void. All of them are. And if you declare a function of type void, then it cannot return anything. So if your function is just going to do something and it doesn't return anything back to the calling program, then you can declare it to be a type void. In addition to that, there are no arguments that come into the function. And if you don't pass anything to the function, then you can put void here as the formal parameter list. But one thing you need to be aware of is when you declare a function to be a type void, the return cannot have any value there. So it's just return with a semicolon. If you do a return with some number, then it's going to give you an error. You can see the little red line show up there. So a void function cannot return anything. It just has to have a return with a semicolon. Now, let's continue and let's look at a different thing, and that's going to be what we call a static variable. Let's scroll down to function 3 and let's add some code there. So I'm going to paste this in and then we'll talk about it. Okay, inside function 3, I've got a local variable number and I've set it to the value 3. Then I've got a cout statement, so when we call function 3, it just prints out entering function 3, number equals, and it prints out the number, which we would expect to be 3. Then I'm going to add 3 to number, and there's another cout statement where we're leaving function 3, and we'll print out the number now that it's changed. So we would expect to get 3 here, we'd expect to get a 6 here. So now let's go to the main program and let's call function 3. So I'll scroll up to the main program, and I've got some end lines here just to separate this example from the ones we've done already. So now let's call function 3. So I'll paste the code in for that. And this is going to illustrate static variables. But the first thing we'll do, we'll call function 3, and we'll see what the output looks like. Now we have the output, and let's bring it in. All right, so we have all the stuff that we've gone over already, so we don't need to look at that. But when we call function 3, we get the output. We're entering it, we get 3, and when we leave it, we've added 3, so number is equal to 6. Now let's go back to the main program and let's call function 3 again. So if we paste in the call here, then we'll call function 3 2 times in a row. Then let's run the program and examine the output. Now here we have the output. So when we call function 3 the first time, we go in with number set to 3, and it adds 3, we return, and when we're leaving function 3, we get 6. Then the same thing happens if we call the function again. Number is 3. We add 3. We leave the function. We get 6. So we get exactly the same thing each time we call the function. Now, let's make a change to function 3 and notice the difference that we're going to get. So scroll down to function 3, and just to the left of the identifier for number, let's add the word static. Static integer number is equal to 3. Now let's compile and run the program again, and we'll call function 3 twice as we've just done. So now we have the output, and I'll drag it over, and look at what we get this time. Entering function 3, this is the first call. Number is 3. We add 3. We leave the function with 6. But the second time that we call function 3, notice that number is 6. And when we leave it, the number is 9. So by making this variable static, we're telling the system that we want to remember the last value for number 3. When we leave the function, when we return, we want this value to be remembered. So when we've changed number from 3 to 6 and we return from the function, the next time the function's called, number is going to be equal to 6. So we start with 6 and we get 9. So if you want to tell the system to maintain memory of variables, then you can declare them to be static variables. Let's explain this a bit further. And the way I want to explain it is to talk about the lifetime of variables. Whenever you have a program, then you have your main program and it does everything that you want it to do, and then finally it terminates down here at the bottom. Well, whenever your program finishes, then it's unloaded from memory, and then you have to start all over again the next time. So these variables that you declared in your main program, X, A, and B in this case, the lifetime of those variables is the same as the lifetime of your program. The same thing is true for global variables. Once you declare global variables, they remain in effect until your program terminates and exits memory. But in the case of functions, in this case we look at function 1, then here x is equal to 2. This variable has a shorter lifetime. Integer x equals 2, that only comes into existence when you call function 1. As soon as you return from function 1, then this integer x equals 2 is no longer in memory. It's gone. So it has a lifetime that's only as long as the function executes. When you declare a variable to be a static variable, then what you're indicating is you want this variable to have the same lifetime as the main program. So the static variables are going to be in memory as long as the main program. Their lifetime is going to be as long as any other variable that's in main or global. But local variables, they don't get to live as long. They only exist as long as your function is executing. Well, let's continue with our example, and let's go down to function 4. Let's put some code in there. So I'm going to paste this in. So we'll print out that we're entering function 4, and we'll print out value 1, and we'll print out value 2. Now, what's that n doing there? Let's take that n. We don't want that in there. So this function has two parameters. We have an integer value 1 and an integer value 2. So again, these are called formal parameters. When you call the function, you'll have to send in two numbers that will correspond to these two integer values here. We will print them out when we enter the function. Then inside the function, we'll set the values for value 1 to 50, value 2 for 70, or 270. Then we'll print them out again. So we'll enter the function with a couple of values, we'll change them, then we'll print them out again here. Now let's call function 4 from the main program. In the main program, I'm going to print out some blank lines to separate this example from the previous one. Now let's paste in the code for this. So in the main program, I'm going to do the following. I have two variables a and b. Those are actual parameters. And when I call function 4, I'm going to pass in a and b. So the actual parameters a and b will go into the function, and they'll be occupied by the formal parameters value 1 and value 2. So here's what will happen. We're going to print out. In the main program, we'll print out A, we'll print out B. So that should be 10 and 20. That's what we have here. Then we're going to call function 4. We'll call function 4 here. It does what it does. Then we come back to the main program, and we'll print out A and B again. So the point here is, will the function change a and b or will it not? So let's run the program and see what we get. The program's running. Here's the output. Now, in the main program, we do get a is 10, b is 20. Then we'll call function 4. Then, if you look at the code for function 4, you'll see we got these output statements here. Then we want to look at the output from that. So we're entering function 4, and we get the value 10, and we get the value 20. So for these parameters, we send in A. A is the actual parameter. Value 1 is the formal parameter. So when we call the function, the value 10 is brought into the function, and it's assumed by value 1. And the same thing for value 2. B is 20. We send in the actual parameter B, and the number 20 is taken on by value 2 when you get to the function. So regardless of how you call the function, these things are not going to have a value until you call the function and you pass values into the function. All right, now going back, we're entering function 4. We have value 1 is 10, value 2 is 20. We change those values to 50 and 70 so that when we leave the function, value 1 was reset to 50, value 2 is reset to 70. But when we get back in the main program, A and B have not changed. A is still 10, B is still equal to 20. So what is happening here? Well, when you do a call by value, which is what this is, then you send in the values for A and the values for B, but if you change them inside the program, then they are not changed from the calling routine. They're not changed back in the main program. So with a call by value, this function cannot permanently change the values of A and B. And if we go back to the main program, you can see that. Okay, we printed out A and B before, we called function 4, and when we got back, we printed out A and B, and it did not change. So when you call a function by value, what is really happening is this: a copy of A and a copy of B, or in general, a copy of whatever you're passing in here is made, a copy's made, and that's sent to the function. The real parameters that exist in the main program, those are not sent in, only a copy of them. So this is like if you're mailing in an important document, you don't want to mail in the original document, you want to make a copy of it and send that in. You want to hang on to your original document. So that's the analogy you can use here. So this is calling a function by value. Now let's move on to our last function, function 5. This one is very similar to what we just saw with function 4, but notice in function 4 we had the formal parameter listed like this, but in function 5 we have this ampersand over to the left. So we're going to add that into our list of formal arguments. So we still have an integer, we still have value 1, but now it's got this special symbol, this ampersand. How is that going to change things? Well, let's paste in the code, and it's almost identical to what we had earlier. We're going to call function 5 with A and B, and we're going to print out the values. And it looks like I'm printing them out twice, so I don't think I want to do that. So let's take that out. We only need to print them once. Okay, so we'll enter function 5 and we'll print out value 1, we'll print out value 2. We'll change them to 50 and 70, just like we did in the previous example. And then we're going to leave function 5 and we'll print out the values after they've been changed. So this is internally, the code that we have here is the same thing that we had in function number 4. The only difference is got those little ampersands. Now let's go back to the main program and let's call function 5. So let's add the code to the main program. I'll skip a few lines, and now we're going to call function 5, and we're going to call it by reference this time. So we'll print out the values for A and B in main. We'll call function 5. We'll come back to main. We'll print out A and B. So what will happen this time? Is A going to be different? Is B going to be different? Well, we'll find out. Now we have the output. So this time, when we bring it over, look at what we get. So here is the case for function 4. And when we came back to the main program, A and B were still the same as when we left. When we're calling function 5, though, notice what we get. In main, A is 10, B is 20. We call function 5 by reference. We enter the function 5, and we get values 10 and 20 for value 1 and value 2. But we change them to 50 and 70 when we leave function 5. Then, when we get back to the main program, look, A is now changed. A is 50, B is 70. So when you call a function by reference, the function is able to change the values of the actual parameters that were used to call the function. Now, that is a lot of information in this program. Okay, call by value. We send in a copy of the actual parameters. Those are passed into the function. Function 4 cannot alter the variables A and B back in the main program. So when you do a call by value, then you don't have to worry about the functions changing the actual parameters that you send in. But if you're calling by reference, then you do have the ability to change the actual parameters with the function. So let's put that comment here. When there's a call by reference, we have the addresses of the actual parameters A and B. They are passed into the function. Any changes that function 5, in this case, any changes made by the function, they are retained by the variables A and B after the function returns. So with call by reference, you send in the actual address in memory where these parameters are stored. And when the function gets those addresses, it can change the contents of those addresses. In the case of call by value, you don't send in the address, you send in a copy of the variables so the function cannot change the values in the main program. Now let's summarize the scope rules by putting some comments here. And here they are. Okay, local variables are visible only within the block of code where they are defined. So in this case, in main, X, A, and B are local to main. Global variables are visible to all functions in the program. So if you declare global variables here, then every function can see those variables. And the other rule is if there's a local variable that has the same identifier as a global variable, then the local variable takes precedence. So in our example, X is that example. X is local here. It takes precedence over the global X up there. All right, so you've been introduced now to a lot of things, the scope rules, the static variables, and calling a function by value and calling a function by reference. So please make sure you understand all of these terms. That brings us to the end of this video.